Okay, we are in the final video for today's lesson, looking at the Unit 7 Day 5 notes. At this point, some of you may have flown through or didn't even do the Unit 7 Day 4 homework or the Unit 7 Day 7 warm-up. I would highly recommend going back to that, okay? As we progress through the video may be long. Please remain focused during the video. I cannot stress enough how important this video is going to be and how important this lesson is going to be once we get to Friday, which again, as a reminder, is a review day for your quiz, which is next week. Okay. Excuse me. Nope, wrong notes. There we go. Okay, so at this point, right, last class, we talked about 3 special parallelograms. We talked about rhombuses, rectangles, and squares. Today, we are not going to be talking about parallelograms. Okay, so as I looked at the tree earlier, we have looked at parallelograms, rectangles, rhombuses, and squares, and all the properties involved. Today we are going to look at trapezoids, isosceles trapezoids, and kites. We are looking at quadrilaterals, not necessarily parallelograms. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Those parallel sides are called the bases. The base angles of a trapezoid are 2 consecutive angles whose common side is a base. Here's what that looks like. We have BC and AD. Those are our bases as they are our parallel sides. The 2 angles that are formed by one of these sides would be considered base angles. So angle A and angle D, or angle B and angle C. The first property that we have, well, 1, the definition, 1 pair of opposite parallel sides. The next property that this has is that the consecutive, not base angles, consecutive non-base angles, really should change that, but this will do for now. Consecutive non-base angles are supplementary. So our base angles are not supplementary. Our non-base angles are. So for example, this could be 60 and that could be 120. Maybe this is 70 and that's 110. There does not necessarily have to be a relationship between our base angles, A and D or B and C. If the legs, these are our non-parallel sides, right? Our non-parallel sides. If they are congruent, then we are looking at an isosceles trapezoid, right? So hopefully we see the difference here. AB, CD, those are clearly not the same length, but here they're marked as congruent. They are congruent. In an isosceles trapezoid, we have the same 2 properties that we had above. There's 1 pair of opposite parallel sides. Consecutive non-base angles are supplementary. And the one thing that we add to be an isosceles trapezoid is that the non-parallel sides are congruent. There is a property about the angles which we will observe in a few minutes. Right now we're going to look at the coordinate plane. We are going to show that this figure right here is in fact a trapezoid and then determine whether it is an isosceles trapezoid or not. In order to determine if this is a trapezoid, we need to see if it has 1 pair of opposite parallel sides. Just 1 pair, not 2. Step 1, find the parallel sides. Well, I can clearly see that RO and ST are not going to be parallel. Right? Those are opposite sides, but if I continue them, those are going to intersect. So I'm not looking at those. Instead, I'm going to look at the slope of RS and the slope of OT and see if they are actually parallel or not. RS has a slope of 1 over 2, and OT has a slope of 1, 2 over 1, 2, 3, 4, 2 over 4, which just reduces to 1/2. So both of those have a slope of 1/2. They have the same slope. The slope of RS was 1/2. The slope of OT was 2 over 4, but that's reduced to 1/2. What does that tell us? That tells us that RS is parallel to OT. That those opposite sides are parallel. Not both of them, right? Because again, clearly RO and ST were not parallel. So we know that we're dealing with a trapezoid. We've shown that it's a trapezoid at this point. Now we have to decide whether or not it's an isosceles trapezoid. In order to determine that, we are looking to see if the legs are congruent. The legs are our non-parallel sides, RO and ST. We already identified those. Are they congruent? That's our step 2. Find the length of the non-parallel sides. Find the length. How are we going to find the length of a side in the coordinate plane? Well, if it's RO, it's pretty easy, right? RO, we can just count. 1, 2, 3. The length of RO is 3. But ST, yeah, we can't really count that. Right? So how are we going to find the length of that side? Distance formula. We need to use the distance formula with the points S and T. Distance formula, ST is equal to the square root of 4 minus 2 squared plus 2 minus 4 squared. 4 minus 2, that's 2 squared, that's 4. 2 minus 4, well, that's negative 2, but negative 2 squared is just 4. Square root of 4 plus 4 is just the square root of 8. So we found the length of RO to be 3 and the length of ST to be the square root of 8. Are they the same? Are those the same length? No. The non-parallel sides are not congruent. It's a trapezoid, but it is not an isosceles trapezoid. Right, you can look and see what the square root of 8 is. It's 2 point something. If that was instead the square root of 9, well, the square root of 9 is just 3, so then they would be, but that's not the case here. You can do the same with this problem. If you want to give this problem a try, please pause before I reveal the answer. If not, I will reveal the answers and talk about it in a moment. Please go ahead and pause if you want to try this. I need to show that ABCD is a trapezoid, so I need to show that BC and AD actually are parallel. And then I have to decide whether it's isosceles. So I'll have to show that those two sides are congruent or not. BC and AD, they both have a slope of negative 1 over 3. Right, that's down 1 over 3, down 2 over 6, down 2 over 6. That's going to be negative 1 over 3, which matches BC. So those sides are parallel. Yes, we do have a trapezoid. The non-parallel sides are AB and CD. We can find the length of both of those sides using the distance formula. AB, we get the square root of 20. CD, we get the square root of 26. Are they the same? No, they're not. Non-parallel sides are not congruent. What does that tell us? We're dealing with a trapezoid, but it is not an isosceles trapezoid. Okay, now we're going to move into a couple of the properties that we have about a trapezoid's angles, more specifically an isosceles trapezoid. We already went through the properties of just a trapezoid and its angles, right? In a trapezoid, there is no relationship between their base angles, but non-base angles are supplementary. We also don't know anything about the opposite angles, right? There's nothing there. There's no relationship there. But in an isosceles trapezoid, we do have a couple of properties. If a trapezoid is isosceles, then each pair of base angles is congruent. So just like I said before, if we're looking at a normal trapezoid, there's no relationship between those two angles. But if we're looking at an isosceles trapezoid, we have two pairs of congruent base angles. So maybe we'll say angle B is 60. Well, then that means angle C has to be 60 as well. Angle A would have to be 120 since these are supplementary and add to 180 because it's still a trapezoid. So these angles are still supplementary. Well, it's the same thing on the other side, so that's got to be 120. Base angles are congruent in an isosceles trapezoid. That's our first property. Our second one is that if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. Well, this is pretty similar to the one above it. But we can do the same whether we have two pairs or just one pair. Right? Again, I'll use the same example. If this angle is 120, that means that angle over there has to be 120. Well, you might be thinking, well, we don't know that B and C are congruent. Yes, you do. I know that these two angles have to add up to 180, which means that has to be 60. I know that these two angles have to add up to 180, which means that has to be 60. So if I have one pair of congruent base angles, I know that the other pair of congruent base angles is there as well. And then the last property that we have is regarding the diagonals. A trapezoid is isosceles if and only if the diagonals are congruent. This is a shared property that it has with rectangles. Right? Clearly, we know that this is not a rectangle for a couple of reasons. One, it's not a parallelogram. Two, all the angles are not 90 degrees. But in an isosceles trapezoid, the diagonals are congruent. So AC would be the same length as BD. Okay, let's take a look at some examples, especially dealing with the base angles property. We have a trapezoidal doorway / hallway / window, I don't know. We want to find angle M, angle K, and angle L. We have parallel bases, JM and KL. We also have, and it's very hard to see in the picture, but we do have that JK, well, that red highlighter did nothing. JK is congruent to ML. So not only do we have parallel bases, but we also have congruent legs. That tells us that we're dealing with an isosceles trapezoid. So I use that information to determine that we are dealing with an isosceles trapezoid. What do I know from here? Well, I know that angle J has to be congruent to angle M because they are base angles. And in an isosceles trapezoid, base angles are congruent. So angle M also has to be 85 degrees. I know it's very hard to see with this picture, but that's got to be 85 degrees. We also know, since it's a trapezoid, that angle J and angle K, they are non-base angles, they are supplementary, which means they add up to 180, which means that angle K and angle L have to both be 95 degrees. A couple different ways you can go about getting angle L, right? Once you determine that angle K is 95, then you know that those two base angles have to be congruent, so that's how I get L. Or you know that angle M is 85, and I know that angle L and angle M are supplementary, right? A couple different options there. But in the end, what do they all have to add up to? 95, 95, 85, 85. They all have to add up to 360 degrees because we are dealing with a quadrilateral. I'm gonna skip this problem for I'm gonna skip this problem for now. All right, if you want to pause it and give this problem a try yourself, go ahead. There you go. If you are confused on this and have any questions, we can talk about this next class. Okay. Now we are going to talk about the mid-segment of a trapezoid. The mid-segment of a trapezoid is the segment that connects the two midpoints of the legs, right? So I have one leg here, one leg here. The mid-segment is in the middle of each of those legs. We have a mid-segment property. It's also good to note, it doesn't say it here, but the mid-segment is parallel to our bases, right? It's right in between our two bases, and it is parallel to our bases, right? So our mid-segment couldn't look like this. When I am trying to find the mid-segment or the length of the mid-segment, and you'll see the type of problem that we're going to see, it's important to me that I note a couple of things. One, I call the mid-segment M. Two, I just call one of my bases base 1. And lastly, I just call my other base base 2. Right? I have 2 bases and the mid-segment. The mid-segment is the average of my 2 bases, right? The average length of my 2 bases. Well, how do we find that? In order to get the mid-segment, we add the length of our bases, so base 1 plus base 2, and then we divide it by 2. That's how we find average. It's the average length. Base 1 plus base 2 divided by 2 is going to get me the length of the mid-segment. Let's see this in action. In the diagram, MN is the mid-segment of trapezoid PQRS. MN. It's right in the middle. I'm just going to call that M, my mid-segment. Well, base 1 is what I'm going to call PQ. My base 1 is 12. That means my base 2 down here is going to be 28. And all I'm going to do is I'm just going to take this information, substitute it into that formula that I have. The length of my mid-segment, M, is equal to base 1, 12, plus base 2, 28, divided by 2. 12 plus 28 is 40. 40 divided by 2 is 20. So the length of MN, the length of our mid-segment, is 20 inches. It is the average of 12 and 28. It's right halfway through those. I can also do the same thing if I'm given some different information, right? So instead of looking for the mid-segment, the names are a little off here, but it's okay. Instead of looking for the mid-segment, I have the mid-segment. The length of the mid-segment is 19. Well, I know that one of my bases is 13 and my other base is, well, that's what I'm looking for, right? So I'm looking for base 2. I have base 1 and I have my mid-segment. So I'm going to use the same formula that I just used, except I'm substituting different information, right? My mid segment is 19. My base 1 is 13, and my base 2 is x. Or I could just leave that as B2. Either would be fine. Excuse me. From here, 13 plus x divided by 2, well, that's an x in the numerator. I got to get rid of this denominator. How am I going to do that? By multiplying both sides by 2. That's going to say goodbye to that denominator. And I'm just left with 13 plus x. Make sure I multiply that 2 on the left side. 19 times 2 is 38. Subtract the 13. X is equal to 25. So my base 2, dg, is 25. I had the mid-segment. I had one of my bases. I can work to find the next base. Does any of this change when we're dealing with decimals? No. Right? Find the mid-segment, even though your bases are both decimals. Find your second base now that I know that my mid-segment is 12. Please go ahead and give these a try. Pause the video and give these a try before you resume it and see the answers. Okay. You should have gotten 16.2 for the first and 15 for the second. Given both bases, find the mid-segment. Given the mid-segment and one of the bases, find the other base. Right, again, making sure here that I multiply both sides by 2 in order to get that numerator by itself, in order to get 9 plus x alone by itself. Okay, and this introduces us, or I guess this leads us to the last type of quadrilateral that we are going to look at this unit, a kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides. Consecutive congruent sides, but the opposite sides are not congruent. Consecutive, that means next to, right? So I have this side right here, next to that is this side right here. Those are congruent. This side right here, next to that is this side right here. Those are congruent. Opposite sides are not congruent. They are not congruent. Two pairs of consecutive congruent sides. That makes a kite. The only other time you would see consecutive congruent sides is when you're dealing with a rhombus, where all four sides are congruent, right? That side is congruent to that side, is congruent to that side, is congruent to that side. Or a square, because a square is also just a rhombus. We have two properties that we're going to look at with kites. One of them regards the diagonals, and one of them regards the opposite angles. If a quadrilateral is a kite, then the diagonals are perpendicular. Similar to how they were in a rhombus, diagonals are perpendicular. They make 90-degree angles right there. Diagonals are perpendicular. This is a challenging property. The last one that we have is that if a quadrilateral is a kite, then one pair of opposite angles are congruent, but it's not just any random pair. There is a specific pair of angles that are our congruent angles. We're dealing with a kite if one pair of opposite angles are congruent. The congruent angles are between the non-congruent sides. This is how I think of it. You may think of it a different way. You might remember it a different way, and that's fine. One way that I've seen people say it before is the angle between the congruent sides is not congruent. It's true, but the congruent angles are between the non-congruent sides. So BC and CD are not congruent. So I'm going to mark that angle. BA and AD are not congruent. So I'm going to mark that angle. Those angles are congruent to each other. The angles that are formed by the not congruent sides. Non-congruent sides. So maybe this is 120. That would mean this has to be 120. There is not a relationship between the angles, or the last two remaining angles, right? These don't have to be the same. They're not necessarily bisected in any way, right? Angle B and angle D, there's not necessarily a property with them. We know that one pair of opposite angles are congruent, but it is a specific pair, not just any random pair that we want. Okay. Find the measure of angle D in the kite. I know we're dealing with a kite because the problem tells me we're dealing with a kite, but I see that DG is congruent to FG, consecutive sides. DE is congruent to EF, consecutive sides. So, ED and DG are not congruent sides. So I'm going to mark angle D. EF and GF are not congruent sides. So I'm going to mark angle F. Those are my congruent angles. Those are my opposite congruent angles. Another way that I could see this, if I'm given a problem like this in particular, 73 and 115, are those the same? No, they're not the same. So those cannot be my opposite congruent angles. D and F would have to be. Sometimes that would help, sometimes it wouldn't. It really just depends on the type of problem that you're given. Well, I'm still dealing with a quadrilateral. So I know that angle D, angle G, angle F, and angle E all have to add up to 360. Angle E and angle G. Angle E is 115. Angle G is 73. And I know that angle D and angle F have to be the same measure. So I'm just going to call both of them X. Angle D is X. Angle F is X because they're congruent. They're the same. I can call them both X. Angle E is 115. Angle G is 73. 2X is equal to 172, right? That's just isolating my X, combining them together. X is equal to 86. So angle D is 86 and angle F is 86 degrees. Those are my opposite angles that are congruent. Angle B and angle D, are they the same? No, one of them's 80, one of them's 50. So are these my opposite congruent angles? Nope, they can't be. So I know that angle C and angle A are my congruent angles. That's one way. Another way. BC and DC are not congruent, so I'm going to mark that angle. BA and AD are not congruent, so I'm going to mark that angle. And I know that angle A is congruent to angle C. We can call them both X. I know that all of these angles, just like any quadrilateral we're looking at, they all have to add up to 360. 2X is equal to 230. X is equal to 115. Angle A and angle C both have to be 115 degrees. Again, like I said, right, this is probably one of the tougher properties that we have because it is just tough to recognize when we're dealing with a kite, our non-congruent sides, the angle that's formed between them, right, everything like that. But we will work on that, especially next class during our review. We have looked at 1, 2, 3, 4, 5, 6, 7 types of quadrilaterals. 7 types of quadrilaterals. They all have different properties, right? But they all do share some basic properties. They're all quadrilaterals, which means they all have 4 sides, right? Every single one of these has 4 sides. They're all quadrilaterals, which means all of their interior angles have to sum to 360 degrees. Right? Those are just 2 properties of quadrilaterals that all of these are going to have. A smaller group of quadrilaterals are parallelograms, where we have 5 different properties that we looked at. A smaller group of parallelograms are rectangles and rhombuses. An even smaller group, right, if it's a rectangle and a rhombus combined, we're dealing with a square. It's like a family tree in a sense. Kind of. Quadrilateral, well, it's not a parallelogram, it could be a trapezoid or a kite. Well, only one pair of opposite sides are parallel, then it's a trapezoid. Well, the 2 non-parallel sides are congruent, then it's an isosceles trapezoid. Well, I'm looking at a quadrilateral and none of the sides are parallel, then you're dealing with a kite if you have 0 parallel sides. With this, we're going to be asked and given a figure and asked to determine what type of quadrilateral we're dealing with. Now, if I just show you a square, and I give you the properties of a square, sure, we'll call that a square. Yes, you can tell me that this is just a quadrilateral. But that's not the only name you can give it. Well, you can call it a parallelogram. Well, you can be more specific than that. You can call it a rectangle. A little more specific than that. Rhombus. You can be as specific as calling this a square instead of just calling this a quadrilateral. And that's what we're going to look at here. What's the most specific name for this quadrilateral A, B, C, D? Well, I only know one thing about this quadrilateral. That AC is being bisected and that BD is also being bisected. Now, are these angles 90 degrees? Maybe. Is BC congruent to AB and AD and C? Maybe. I don't know. The problem doesn't give me enough information. Or not necessarily enough information, but it just doesn't give me that information. All I know is that the diagonals bisect each other. I cannot assume anything about the sides or the angles because I wasn't given anything. The most specific name that I can give is a parallelogram. Right? One of our properties of parallelograms is that diagonals are bisected. Is that the same in squares, rectangles, and rhombuses? Yes, but I don't have enough information to say that this is a square or a rectangle or a rhombus. Only that it's a parallelogram. What's the most specific name for quadrilateral JKLM? Well, let's see. JKLM. I mean, to me, it looks like a rectangle, right? And some of you might immediately just write rectangle. But do I know that these are 90-degree angles? Not necessarily. Do I know that the diagonals are congruent? No. I have one pair of parallel sides. One pair, not 2, only 1. So I can't even be dealing with a parallelogram right now. I know, well, I guess before I get into that, one pair of parallel opposite sides, one pair of congruent opposite sides. That's an isosceles trapezoid. Do all isosceles trapezoids look like that? No, most of them look something like this. But these have the same properties. Those 2 sides are congruent. Those 2 sides are parallel, right? We have a pair of opposite parallel sides and a pair of opposite congruent sides. And that tells me that I'm dealing with an isosceles trapezoid. The biggest thing that I can say right now, don't assume. You cannot assume anything about these shapes. I don't know that all these sides are congruent. I don't know that all those angles are 90 degrees, right? And it's the same over here. All of these figures fall into a tree. They're all quadrilaterals. Some of them are parallelograms, some of them are trapezoids, some of them are kites. If it's a trapezoid, if it has a few more properties, it's an isosceles trapezoid. If it's a parallelogram and it has a few more properties, it's a rectangle or a rhombus. And if it has all those properties combined, then it's a square. Right, again, as I mentioned earlier, it kind of falls into a family tree in a sense, where they're all quadrilaterals, but they can be different based on certain things, based on certain properties. Okay. I know that a lot of you are going to have questions about this. I know that a lot of you, or some of you, might be pretty confused with this, which is why next class is a review. Right, next class we are going to review. We're going to hit this stuff hard at the start of class because I wasn't here. What I would like you to do now is to move into the Day 5 Big Ideas homework. If you are viewing this homework, let me try and find the specific time. If you're in second period, the homework isn't going to open until 10:40 because around 10:40 or after that is when you should be done doing all of these things. If you're in third period, the homework does not open until 1:05 because that's 40 minutes left in class, which is when you should be or hopefully are done with all of these things. Shouldn't really be done with them any sooner. So if you just jumped to the notes and jumped to the homework, it's probably not even open yet. So you might want to jump back to going over the Day 4 homework and looking at the Day 7 warm-up. Next class, when you come in, be prepared, have those problems with work shown on the homework. We'll do a GIM kit during the homework check. I have a review slide that just goes through the properties that we learned today. We're going to go over the homework, move into our warm-up like usual, and then we will have a review activity. And if there's enough time, I will give you some time to work on the homework as a group before our quiz next week. If you have any questions, don't hesitate to send me an email and let me know.